Alright, this is Algebra 1, Chapter 7, page 427 in your book. So if you'll follow along with me in the book, we're going to start a chapter on linear systems. And linear systems are equations, basically two equations that have the same answer for their x and y values. So let's do some defining here. Page 420, to look and see what page this was. Page 427. So the first vocabulary word is system of linear equations. It says a linear system is two or more linear equations. And this is right on the same page that we're on here. In the same variables. That means if one has an x and a y, the other one has an x and a y, or all of them have x and y's. You can't have a system where one has an x and a y and the other one a s and a t. So they have to have the same variables. Okay. Solution of linear equations is an ordered pair. Okay, that's for the two variables. For the variables, it's an ordered pair that works in both or all equations. Sometimes there can be more than one. There can be three in a system or four. So, okay. And then the last one, a consistent independent system is a linear system that has exactly one solution. With exactly one solution. That means one answer. Okay, so let's get into this and we're going to learn how to solve linear systems three ways. We're going to learn how to do it by graphing, we're going to learn how to do it by substitution, and then we're going to learn how to do it by adding and subtracting. So we have to do the graphing, which is back to the stuff we did in Chapter 5 that I know you guys didn't really like very much, but we have to remember it should be a little bit easier now. It's very easy to do this with graphing. Graphing is very visual. You graph the two equations that are given. So in example number 1, the two equations given are x plus 2y equals 7 and 3x minus 2y equals 5. Okay, so the first thing, in the first example, all that it does for you is it gives you the picture. So as far as an answer to a linear system, when they give it to you, the graph already, it's just simply where the two lines cross, where they meet each other. So these cross at the ordered pair 1, 2, 3, 3, 2. And I got that by going over 3 and up 2 right here. So 3, 2 is the answer. Now remember back there that 3, 2 has to work in both of these equations in order for it to be a solution. So let's substitute in right here. We're going to put the 3 right here, and we're going to put the 2 right here. So 2 times 2 is 4. 3 plus 4 is 7. So it works in the first equation. So let's put it in here. 3 goes here, 2 goes here. 3 times 3 is 9, minus 2 times 2, which is 4, and that's 5. So that's your solution. So when they give you the picture, all you do is see where the two lines cross, find the point, check it in the solution in the equations. If they work in both of them, then you have the answer. So it says they appear to intersect at 3, 2. We substitute them in just like they're doing exactly what we did, and they found out that they do work. Okay, so it is a solution. So here are the steps for solving linear systems, graphing them. So the first thing you do is you graph them. So here's step number 1, and you guys write these down. Step number 1 right here. You graph both equations in the same coordinate plane. So you put them both in, I put them both in y equals mx plus b, and then graph it. It says for the ease of graphing, you may want to write them in slope-intercept form, and that's what this is right here. Okay? So you graph it, and I count out the slope a couple of times. You'll see on the example just to make sure our line is consistent. And then it says estimate the coordinates of the point of the intersection. Sometimes they might not exactly pass it in the exact places, so hopefully they'll pass right on the corners right there. So that's exactly what we did, where we saw where the two lines cross. And then step 3, check the coordinates algebraically by substituting them into each equation. Okay, so let's do that. The first thing is I got two equations right here. So the first step says to graph these two equations. So in order to graph these, I need to put them in slope-intercept form. So this one, you just have to get the y by itself. So negative x plus y equals negative 7. So I'm going to add x to this side, add x to this side. Those cancel out. Y equals x minus 7. That's an mx plus b form. The next one, x plus 4y equals negative 8. I'll minus x. Those cancel out. 4y equals negative x minus 8. And divide both sides by 4. And this is where you'll have to remember back. I remember doing this in that last test. There's an unwritten 1 right there. So my slope is negative 1/4 x minus 2, because I divided this by 4 and this by 4. Don't divide out that slope because you want it to be rise over run. Okay, so that's step number 1, is to get it in slope-intercept form so you can graph it. Okay, so I'm going to negative 1/4 x minus 2 and x minus 7. Let me see if I can remember those. Negative 1/4 x minus 2 and x minus 7. Those are my two graphs. Let's see if these graphs, so you would take a coordinate grid and you would graph it. So crosses this one, let's do this one first. It crosses at negative 7, 1, 2, 3, 4, 5, 6, 7. So you'd put a dot right there. Pretend like there's nothing here. We're just doing our lines right now. The slope is 1, so rise 1, run 1, 1 over 1. So there is the first equation. This one we start at negative 2. It's got a negative, go down 1 and run 4. 1, 2, 3, 4. Down, run, 1, 2, 3, 4. Okay, so there's our line, and it's graphed. So then we just say, where do those cross? It crossed at 1, 2, 3, 4, 1, 2, 3, negative. So over 4, down 3, so 4, negative 3 is our answer. Okay, so that's a solution to both of those. So let's put it in and see. We're going to put a 4 in right here and a negative 3 in right here. Negative 4 plus negative 3 is negative 7. Okay, 4 plus negative 3 times 4 is negative 12. That's negative 8. It works in both of them. So 4, negative 3 is the solution to our, and here's, they're just going to substitute it in just like I did. And we'll find out that that ordered pair is a solution for the system. Okay, so here's our first one. Negative 5x plus y equals 0. 5x plus y equals 10. So the first thing you do is you get y by itself. So you're going to go y. You're going to add 5x to both sides, so y equals 5x. This one we're going to minus 5x, so we're going to have y equals negative 5x plus 10. So all I'm doing is getting the y by itself. Now I'm ready to graph these. Let me see if it gives us a graph. Doesn't give us a graph. So the bad part about that is my graph is not going to be very good. Obviously not very good. Let's see. It's at 10. This one's plus 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. So it's at 0. My slope is 5 over 1. So rise 5, 1, 2, 3, 4, 5, and run 1. 1, 2, 3, 4, 5, and run just 1. So, this is going to be ugly. Sorry, guys. There's not a very good line. It's supposed to connect those dots. So this one, it starts at 10, and at 1, 2, 3, 4, 5, and over 1. Oh, thank goodness, look. It's supposed to go through both of those points. This line's supposed to go through that too. So that point is 1, 5. So let's try it and see if it works. We put a 1 in right here and a 5 in right here. -5 plus 5 is 0. We put in 5 plus 5 is 10. So it works. 1, 5 is the answer. Sorry I don't have graph paper, but you guys do. They're going to have to get some more of those little graphs from me. And, ooh, boy, that is an ugly graph. All right, so let's solve this one. So we're going to get -x plus 2y equals 3. I'm going to add x to this side. Add x to this side. 2y equals x plus 3. Divide by 2. Cancel out. Y equals, remember there's an unwritten 1 half x plus 3 halves, which is 1 and 1/2. And that's what I need to graph it. Now let's get this one in slope-intercept form. Maybe my graph will look better. -2x minus 2x, y equals -2x plus 4. So these are the two equations right here that you're going to graph. Remember, the B is where you start. So I apologize ahead of time for my graph. It's not going to be good. 1, 2, 3, 4, 5. I don't know if that's the right. Okay. So 1 1/2 is where it crosses the B, and I rise 1 and run 2. Rise 1, run 2. This is the hard part, is I don't have a ruler to connect my line. Okay, there's this, that's this line right here. Okay, now 4, 1, 2, 3, 4. I'm going to rise 2 and run 1. Rise 2 and run 1. Okay, so it's looking like it's crossing at 1, 2. Okay, and yours would look better if you used graph paper. You'll be able to see it better. So let's check it. We'll put it in right here. We'll put a 1 in here and a 2 in here. -1 plus 2 times 2 is 4. -1 plus 4 is 3. Okay. Put in the 1, 2 times 1 is 2 plus 2 is 4. Yep, 1, 2 is the answer. That's it. So you take the two equations, solve them for y, graph them, where they cross is your answer. And then you should always check it. Okay, so we got another one. I'm just so excited about making these graphs. So x minus y equals 5. I'm going to minus x, -y equals -x plus 5, but I really want it to be positive y, so that changes the values of all of those. 3x minus y equals 3, minus 3x, minus 3x. Whoops, it's a plus right there. So I get y equals -3x plus 3. Okay, let's see if I can graph. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right, so this one crosses at -5, and it's rise 1, run 1. Rise, run. Okay, so the slope is 1. So there's this line right here. Okay, this one's a negative slope, so I know it's going to go in the other direction. So it starts at 3. I'm going to rise over run 3, 1. Rise 3, 1, 2, 3, run 1. I got a feeling it's that point right there. If I can just figure out what that point is. 2, 3? 2, -3. Let's try it. We'll put in a 2 minus -3. Boom, boom would be 5. 3 times 2 is 6, plus -3 is 3. Look at that. Okay, well, just because I was able to do it with these bad graphs, you don't make up your own graphs. Please use graph paper so we can read it better. Okay, so there's linear systems and graphing. So example number 3, a Parks and Recreation department in your town offers a season pass for $90. As a season pass holder, you pay $4 per session to use the town's tennis court. Without a season pass, you pay $13 per session to use the tennis court. Which system of equations can be used to find the number of X sessions of tennis after which the total cost Y with the season pass, including the cost of the pass, is the same as the total without a season pass. Wow, that's a lot. Okay, so what I would do is you go back and let's just write two equations for this one. As a season pass holder, you have to pay y equals, you have to pay $4 per session plus $90. Without a season pass, you just have to pay $13 per session and no other money on top. So let's see what our options are here. So it's looking like C. This is the one without a season pass. This is the one with the season pass. So it's C. There's the one without, and here's the one with, so it's C. So solve the linear system in example 3 to find the number of sessions after which the total cost with the season pass, including the cost of the season pass, is the same. So the worst part about that one right now is that the only way we can solve this, which is y equals 13x and y equals 4x plus 90, is to graph it. So my problem with graphing this is that 90 is huge as far as the size. Trying to think. Even on your pieces of graph paper, it's not the best. I think, couldn't we put these, when would they be equal? They want to know number of sessions, so couldn't we just take these and put them equal to each other? When are they going to be equal? How many sessions? Minus 4x minus 4x. 9x equals 90. Divide by 9, x equals 10. And after 10 sessions, we don't need to be, it didn't ask us to graph, but we didn't need to graph right there. The answer is 10. So we just set the two equations equal to each other and solve for x. So in example 3, suppose the season pass costs $135. After how many sessions is the total cost with the season pass the same? So we still have the 13x. This time equals 4x plus 135. So we'll minus 4x again. So I get 9x equals 135. Divide by 9. 135 divided by 9 is 1. So that one's going to be after 15 times. So 15 sessions for that one. Okay? So graphing, you can graph and put them in slope-intercept form, and then sometimes with story problems you can just set them equal to each other. So let's take a look at this one. It says a business rents inline skates and bicycles. During one day, the business had a total of 25 rentals and collects $450 for the rentals. Find the number of pairs of skates rented and the number of pairs of bicycles rented. Okay, so here's the deal. There's two numbers there. There's the 25 for the total number of rentals, and then there's the 450 for the money. So what we need to do is we need to write two equations, one for the total number of rentals and one for the money. Okay, so let's make the inline skates be x and let's make the bicycles be y. We rented a total of 25 things, whether they were inline skates or bicycles. So x plus y equaled 25. That's our first equation. Okay, now let's do the money. Inline skates cost $15 a day, plus bicycles are $30 a day. And notice I'm putting the letters with them. That equals $450. Okay, so now we're ready. Here's our system. There's the equation for the rentals. There's the equation, and I'm going to use their graph because I know they put it in here. So they graph both equations, so solve them both for y. And notice they numbered their lines by 5. That will probably make your equations a little better there. right here it says they appear to cross at 5, 10, 15, 20, and 5, 20, 5. Okay? So is it a solution? And that means, does it work in both of them? Yes, it does. So 20 pairs of skates and 5 bicycles. So suppose the business has a total of 20 rentals and collects $420. Find the number of bicycles. So 20 rentals would be, this would be X plus Y equals 20. We still have $15 for the skates, $30 for the bicycles, this time $420. So we get Y by itself, so this is going to be Y equals negative X plus 20. This one, minus 15x minus 15x, 30y equals negative 15x plus 420. Divide by 30 on both sides. That cancels out. 15/30 is a half, so that's negative 1/2 x plus, take the 0 off, 3 goes in there 14 times. So here's my, I think this time I'm going to number by 2's. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So it's at 20. Slope of 1 and over 1. That's a little tough. It's going to be really tough to see in my graph right here. And then 14, 2, 4, 6, 8, 10, 12, 14. Rise 1, run 2. Rise 1, run 2. The windows are going to cross. That graph is not working out very good, is it? It says it's 8. Oh shoot, this one's wrong. It's a see, that's not a negative. Rise 1. This, something's not. See, they're both negative. How can they both be negative? Is that right? Minus x 20 plus 14 negative 1/2. It's not showing up very good, is it here? Mine has 8. It's supposed to be at 8, 12. 2, 4, 6, 8. 2, 4, 6, 8, 10, 12. How come it's not crossing? X plus Y equals 20. That's right. 15x, suppose it has, collects 420, 30y. I did that right. I got the 1/2. I got the 33, let's see if I have that right. 3 into 42 goes once. 12, 14, I got that right. It's got to be in the graph. I'm not seeing. Two, 4, 6, 8, 10, 12, 14, 16, 18, 20. And then, you know, the slope is going by 1. I think I'm going to do this one by 1s. 1, 2, 3, 4, 5. So this one by 1s, this one by 2s. So I'm going to go to start at 20. I'm going to go down 1 over 1. Down 1 over 1. So that one's coming down like that. Maybe I just needed it to be steeper. 14, 2, 4, 6, 8, 10, 12, 14. That's right, down 1 over 2. Down 1 over 2. See, it looks like it's crossing better. 2, 4, 6, 8. 2, 4, 6, 8, 10, 12. It's really hard. So it should be at, it says 8 bicycles. The Y is supposed to be 8. 2, 4, 6, 2, 4, 6, 8. Wow. Well, the answer is supposed to be 8 bicycles. Have me do this. I'm going to have to graph this one on the overhead to see if I can get it. Remind me when you get, whoever the first person who gets there, I'm going to graph that one, see if I can figure it out. But my book says 8 bicycles. And if you remember X, I believe that the Y is the bicycles. So it looks like it should be crossing there at 8:12 or 12:8. Then is what it should be, because it's got to equal 20. Maybe my graph, I can't see it in my graph. It's just too hard to do this without graph paper. So anyway, give them a shot. So you remember what you're doing is you're going to graph them first. You're going to find where they cross, and you're going to check your answer in both equations to see if it works. And story problems, sometimes you graph, sometimes you can set it up like we did and put them equal to each other, or you can graph. It should let you know what you need to do on those. And especially a problem like what we did the last example in this last guided practice is you can write 2 equations from the same information. Sometimes one involves the number of something, the other involves money. So give them a shot and have fun. This is the only one in here that you have to do graphing, and then the rest will incorporate some algebra into it. All right? Okay, see you next time.